Conditions required geysers. Hot rocks below, an ample groundwater source, a subsurface water reservoir, fissures to deliver water to the surface. Generally, all geyser field sites are located near active volcanic areas, and the geyser effect is due to the proximity of magma. General surface water works its way down to an average depth of around 2,000 meters, where it contacts hot rocks. The resultant boiling of the pressurized water results in the geyser's effect of hot water and steam spraying out of the geyser surface when a hydrothermal explosion. Worldwide, there are only about 1,000 geysers, and most of those are located in Yellowstone National Park. Most of the world's geysers occur in just 5 countries: the United States, Russia, Chile, New Zealand, and Iceland. All of these locations are where there is geologically recent volcanic activity and source of hot rock below. The formation of geysers specifically requires the combination of 3 geologic conditions that are usually found in volcanic terrain. Intense heat. The heat needed for geyser formation comes from magma that needs to be near the surface of the earth. The pressures encountered at the areas where the water is heated makes the boiling point of the water much higher than at normal atmospheric pressures. Water. The water that is ejected from a geyser must travel underground through deep, pressurized fissures in the Earth's crust. A plumbing system. In order for the heated water to form a geyser, a plumbing system is required. This includes a reservoir to hold the water while it's being heated. The pumping system is made up of a system of fractures, fissures, porous spaces, and sometimes cavities. How do geysers work? To understand how a geyser works, you must first understand the relationship between water and steam. Steam is produced when water is heated to its boiling point. When water converts into steam at surface conditions, it undergoes an enormous expansion because steam occupies 1,660 times as much space as the original volume of original water. The eruption of a geyser is powered by a steam explosion when boiling hot water suddenly expands into the much more voluminous steam. To summarize, a geyser erupts when superheated groundwater confined at depth becomes hot enough to blast its way to the surface. Here, what happens in the ground? Cool groundwater near the surface percolates down into the earth. As it approaches a heat source below, such as hot magma chamber, it's steadily heated towards its boiling point. However, at the boiling point, the water doesn't convert into steam. This is because it's deep below the ground, and the weight of cooler water above produces a high confining pressure. This condition is known as superheated. The water is hot enough to become steam. It wants to become steam, but it's unable to expand because of the high confining pressure. At some point, the deep water becomes hot enough, or the confining pressure is reduced, and the frustrated water explodes into steam in an enormous expansion volume. This steam explosion blasts the confining water out of the vent as a geyser. There are 2 types of geysers: fountain geysers, which erupt from pools of water, typically in a series of intense, even violent bursts, and cone geysers, which erupt from cones or mounds of siliceous sinter, also known as geyserite, usually in steady jets that last anywhere from a few seconds to several minutes. Old Faithful, the best-known geyser at Yellowstone National Park, is an example of cone geyser, and also at Yellowstone National Park is an example of fountain geyser. The intense transient forces inside erupting geysers are the main reason for their rarity. Most geysers form in places where there is a volcanic theolite rock which dissolves in hot water and forms mineral deposits called siliceous sinter or geyserite along the inside of plumbing systems which are very slender. Geysers are fragile phenomena, and if conditions change, they can go dormant or extinct. Many geysers have been destroyed by people throwing litter and debris into them. Others have ceased to erupt due to dewatering by geothermal power plants. The specific colors of geysers derive from the fact that despite their apparently harsh conditions, life is often found in them and also in other hot habitats, in the form of thermophilitic prokaryotes. No known eukaryote can survive over 60 degrees Celsius as they have heat-stable enzymes that retain their activity even at high temperatures. They use as a source of thermostable tools, they are important in medicine and biotechnology. Example in manufacturing, antibiotics, plastics, detergents, and fermentation products.